I'm Bill Hupsher.
And I'm Lori Meggs. On today's episode of Focus on Marshall, Bill, have you ever crushed a soda can in your hands?
Well, sure.
Well, there are folks at Marshall who actually get paid to do that, and I'll tell you what they're testing.
But first, here in the Rocket City, we're very familiar with engine tests out here on the Arsenal, rattling windows across the city. Well, we're going to go to one engine test that isn't rattling windows, but is still very important to the Aries program. We're at Test Stand 116 in the East Test area at the Marshall Space Flight Center, and we're joined by Steve Harvison. He is the engineering lead for the Ullage settling motor. And Steve, first of all, if you would, tell us a little bit about Ullage and why we need a motor for it.
Well, the Ullage settling motor is trying to settle the air gap in the upper stage propellant tanks. We're trying to settle the liquid fuel down to the bottom of the upper stage right prior to the J2X engine start.
And why is that so important?
Well, you want to keep those propellants located in the right place to get a good ignition transient for the upper stage to fly away from the first stage. You don't want the propellant sloshing around. That could change the propellant characteristics.
And Steve, you just completed a major milestone here just yesterday, in fact, here at the test stand. Why don't you tell us about what happened here?
We had a great successful test yesterday of this Ullage settling motor. It's a solid propellant rocket, about 9 inches by 47 inches. This was the first in a series of 4.
And tell us how the Ullage will fit into the mission of the Aries rocket.
Well, it's a solid rocket motor that's going to be strapped to the upper stage, and it's going to make sure we have a good separation between the first and the second stage, and like I said, settle the propellants and get us on our way to our mission.
Why is this particular test stand so important and so useful for you guys with Ullage motor tests?
Well, we can handle all our problems real time here. We actually built this test motor here at Marshall Space Flight Center, did all the design and all the fabrication here. With the Army here on the Arsenal, we actually loaded the propellant. We test here and we can solve all the problems real time.
And it looks like the motor right here has been capped and is ready to be moved. Where is it going from here?
They're about to move it over to another building where we can disassemble it and do a forensics of all the data we've collected on the motor and take it apart and look at all the internal insulation and make any design tweaks that we need to. And then we'll carry on with the other 3 tests.
Steve, we look forward to following your progress and seeing it fly. Thanks very much.
All right, thank you very much.
We're in building 4619 at the Marshall Space Flight Center and are in the load test annex, a very large open structure, to talk to Michael Lau. He is a structural test lead here at Marshall. Mike, thanks very much for joining us. First of all, tell us a little bit about this space and what kind of testing goes on here.
Well, we are the large-scale structural and dynamic testing facility for NASA. So all large-scale structures that need to be tested for development and qualification would come to this facility to be tested.
Now explain to us a little bit about what load testing is.
Well, any of the kind of loads that a vehicle would experience during pre-launch, launch, or space flight would need to be simulated here to qualify the vehicle for launch. And that's the kind of testing we do. We use hydraulic cylinders to apply the loads and data systems to collect all of the strain, deflection, and load that structure would experience during its life cycle.
Well, I imagine then you guys are going to be pretty busy over the next couple of years with the development of new rockets.
That's right. With the Aries 1 and Aries 5 vehicles, all of those new large structural vehicles are going to come here for development and qualification tests.
In fact, I believe Lori is with someone right now who is working on one of those test articles.
That's right.
I'm here with Mike Robertson. He's a test engineer in Marshall's test laboratory. And Mike, you're getting ready for a series of major structural tests for the Aries projects. Tell us about those tests.
Yeah, this test series is called shell buckling tests. NASA Langley approached us about a year ago to perform some testing on metallic cylinders. This particular cylinder here is 8 feet in diameter and 6.5 feet tall, and we're going to apply a compressive force enough to test its strength, the strength of the aluminum lithium material, until it buckles and fails.
Now, what will you do to the cylinder?
Well, we're going to put 8 load lines around the circumference and crush it just like a Coke can, essentially, and apply about 700,000 pounds of force to crush it. Now, the cylinder itself only weighs 275 pounds.
Wow, that's impressive. And it looks kind of like a Dalmatian. Tell me about the spots. What are those all about?
It does. When you compress a cylinder, there's the sides of the cylinder want to either move out or move in. And we have a digital system set up to be able to really accurately provide data of exactly how much it does move out or move in when it goes to failure.
And there's a lot of history of this with Marshall, like some testing back in the 60s that's really led to this series of tests, right?
It did. NASA had a series of tests throughout the 60s, like you say, that determined analytical factors used in the design of any cylinder you see on a rocket. And today that we still use those analytical factors, and all of industry, all of the aerospace industry worldwide uses those factors.
So, Mike, one of the reasons you perform these tests is for the designers.
That's correct. Our shell buckling test article is loaded with instrumentation on the inside and out, and it collects a lot of data during the deformation and loading and during the failure. All that data goes over to the stress analysts and the designers, and that helps us produce lighter weight designs for the Ares program in order to take more payload to the moon.
Give it up, dude. Find out where we turn up next as we focus on Marshall.
This was easier when I was younger.